Bonjour à tous. Hello everyone. Today I will show you how to design reinforced concrete wall pile based on ACI 318, Eurocode 2, BA8110 and CP4 Singapore standard by using manual calculation compared with geodesign. How to design rebar in concrete wall pile. Okay, now let's start from the first introduction about what is the single concrete wall pile. Everyone know about foundation design, everyone know about wall pile definition. For the single concrete wall pile, we refer to only concrete wall pile receive only load without any group, without any other concrete wall pile in the same column position. Okay, in this case we has only one concrete wall pile receive one column, so it's called it a single wall pile. Okay, we want to focus about how to design rebar or this wall pile based on the American code, based on Eurocode, based on Singapore code, and based on UK code. And we will explain you comprehensively about how to design a single pile, why we not design it as a group pile, but for the rebar in a single pile, and in a group pile what is different for analysis and design. Okay, now let's start to the next part. Okay, next page. Okay, we want to talk about column analysis, long column, short column. How about concrete wall pile? We should analyze as a column, long column, short column. We should analyze it as soil spring. Okay, soil spring, or we should design it a section. Okay, a section. So we will find the answer at the end. Okay, now let's continue. And how to choose the concrete strength for wall pile? How you want to choose concrete strength for wall pile 40 megapascal, 50 megapascal, or 20 megapascal, or 30 megapascal? Which one is correct for you? Which one is suitable for wall pile? So we will get the answer in this tutorial series. Okay, how much percentage of rebar you in wall pile? How much? Okay, if you has a section example diameter 1.5 meter, and how much rebar you should use? And each other section like 600 millimeter, how much rebar you should use in your concrete wall pile? And we will talk about soil bearing capacity, which use wall pile bearing capacity, and which one is control for your calculation. Okay, and now I will explain manually about how to calculate based on ACI code, based on Eurocode, based on BA code, based on the Singapore standard. We will discuss more detail and comprehensively by manual. Okay, by hand calculation, and we then compare it with software geoscience, and we will know about how to calculate the rebar. We not focus on the bearing capacity of soil, we focus on bearing capacity of section of concrete wall pile. Okay, it is as I saw previously on the previous page, how to use concrete strength. We will talk in more detail. Okay, and we also talk more detail about rebar in wall pile, and the load and the condition that control our design of soil bearing visual ball pie. And it is an example of our calculation based on different forecasts. You see here, this is summarized result as I combine it in single sheet. You see here, we have to select the link, okay, spiral or tie column, include rebar or not. If you do not want to include rebar in calculation, you just select it and select no, and include eccentricity in section or not, and you just input diameter or ball pile, concrete cover. So everything here will be automatically calculate and compare each other about different code. Okay, different code. This is for the ultimate. Okay, for the ultimate for design rebar. Okay, rebar section. And this one we call it allowable stress or allowable concrete stress. Okay, we verify it as a load. Okay, so visibility limit state. For this one we calculate based on ultimate limit state. So we calculate it to for the rebar. Okay, and you see here it is summarized for the ACI code. Okay, I just put material and geometry, so we will convert everything and compare each other. Okay, and we will talk about the limit for the concrete. Okay, what is the limit strength or limit strength of the concrete based on Singapore code. We will talk more detail and the part. Now you see here it is briefly about reaction, internal force or single part. You see here the shear force. This one is the moment, this one is displacement. The three is very important for our calculation, analysis and design. We will take all this force to calculate for the rebar and to verify with our section. Okay, you see here it is the summary result output from GeoFile software, and then we will calculate with Excel sheet, compare with GeoSign or GeoFile to compare each other with bearing capacity of the concrete ball pile. Now we not focus on soil bearing capacity, we focus on leave for the concrete bearing capacity. Okay, you see here I just explain you briefly about the concept of single pile and group pile. For the calculation of bearing capacity of soil, it is very important to classify its single pile and group pile, because you see here the stress zone that overlap each other about stress distribution on the soil. You see here, so the bearing capacity of group pile will be reduced. It is the efficiency by using the Q2 divided Q1. You see Q2 Q1. Okay, here for the single pile and here for the group pile. After you divide and compare it, so the bearing capacity of soil will be reduced less than 1. Okay, so the chart remember that each your single pile can soil bearing capacity can bearing 100 tons, but in the group pile will be bearing less than 100 tons. Example for 80 tons only. Okay, it is a concept for the difference between single pile and concrete pile for the soil bearing capacity, but in rebar, for calculating rebar it's not different. Okay, we just use the internal force to calculate for the rebar, but for the single and group pile effect for the bearing capacity of soil, you should remember about this one. Okay, you see everything about briefly about settlement and load and about distributed stress zone. You see here. Okay, you see here. For calculation soil bearing capacity, we can design a single pie or group pie as I explained you previously. And for analysis and design rebar and stress of the cross section, we focus on the internal force. Okay, after you apply the internal force, okay, apply internal force, you will get internal force. We take internal force to analysis. This is very important. Okay, we consider about the moment, about the shear force, and about the shear, and other one is about deformation. It is a very important parameter for analysis and design in concrete ball pie. You see here, it is a group pie. We analyze it in group pie. After that, you will take one pie to calculate for the rebar. Okay, you use one pie by using the internal force M and V and deformation, etc., to calculate rebar. Okay, this is very important. You do not calculate group reinforcement. Okay, you calculate single reinforcement for single pie. Okay, we apply it other pie. Okay, apply to other pie, it's the same. Okay, this one is the same. We got the result from the analysis, and we will take the result to calculate the rebar. Okay, this is the concept why I say about the difference between analysis single pie and group pie for the soil bearing capacity. But for the design or the rebar is not different after you got the analysis result. Okay, the process is the same. You see here, sometimes you can use metal soil spring to analyze pie. Okay, sometimes you can use a tape, use robot, do other analysis software to analyze and design this type of the soil spring. You assign soil spring with the material of the concrete and assign any other support. Okay, at the bottom is soil spring, and you analyze this. Okay, but I don't want to focus about this one. I just focus about how to design it easily by using hand calculation and verify it with geoscience. Okay, thank you for your watching. Thank you.